Hi guys, welcome. In today's lesson, we are going to talk about odd and even functions. You see that? One thing that you should know is that we have these two important classification of functions as either odd or even functions. But that doesn't necessarily mean that any function must belong to one of these two groups. So sometimes a function can be neither of these. We can have functions that are neither odd nor even functions. But today we want to understand what is it that makes an odd function and what is it that makes an even function, and then see some examples of such type of function, and even maybe talk about examples of functions which are neither odd or even functions. You see. So let's start by giving formal definitions of these. You see. So let f from A to B, for now, what we're going to assume is that we want to deal with functions whereby now they map real numbers to real numbers. So we'll just assume that A and B, they take values that lie in the real numbers. So let f be a function. You see, so let f which shares some domain A and codomain B be a function. Then one, we say that f is an odd function if, so we say a function is odd if it is the case that f of x is equivalent to saying f of minus x. So any function that satisfies this condition is said to be an odd function. Then two, we say that f is an even function if f of x is equal to f of minus x. You see, so if it is the case that f of x and f of minus x are one and the same thing, then we say the function is even. You see that? We say the function is even. So let's practice these definitions that we have here. So typical problems that one can get in this section will be as follows. You see that? So given, or they will say, is the function f of x equal to x cubed minus x even or odd? These are typical problems that you can get in exam, where they give you a function and they want to check if it's even or odd, or even neither. So there is a possibility of neither as well. So how can we test if this function is either even or odd or neither? So what we do is we can check all those properties at first. So at first we'll try and check if f of x is equal to f of minus x. That's what we'll do. So to do that, what I'm going to do now is, already I know what f of x is. So my main focus now will be to check what is this thing now. What is f of minus f of x? You see, so now what is minus f of minus x? It is the same as saying minus f of minus x is the same as saying minus x cubed minus x, like that. You see. And what does that give us? We get minus what? So we know that minus x cubed is just minus x cubed. And minus there we get plus x. If we multiply by this negative outside, we see that we get x cubed minus x. And we can see that this is just the same thing as f of x. So therefore we can conclude and say, therefore f of x equals to x cubed minus x is an odd function. You see, so this function that we have here is odd because we see that this is true. But one thing that you should know is that you can't have a function that is both odd and even. It's impossible. So that's why when one thing agrees to be true, we can make the conclusion without the need to check if also the function is even or not. So we don't have to go that far to check for that. So let's see some other examples too. So another example that you can get will be is f of x equals to x to 4 minus x to 6, even or odd or neither. So that's the question that we are given now. We want to check if this is either even or odd or neither. So solutions. So at first we'll check for odd. You see that? So we'll check if minus f of minus x is equivalent to f of x. So what is that? It's minus x raised to 4 minus x raised to 6, which will give us minus x to 4 minus x to 6. So we see that this is just minus f of x. So it's not true that f is odd. So we can see that therefore f is not odd. So this is what we can conclude from here, that f is not odd. So what we do now, we can check if it's even instead. You see that? So now to check that it's even, we calculate f of minus x, which is just the same as saying minus x all raised to the power 4 minus x all raised to the power 6. And then what do we get? So when we simplify this, we see that we get x to 4 minus x to 6, which is still same as f of x. So therefore the conclusion here is that f is even. You see, so we can see that simple, it follows that x is even here. So yeah, these are typical examples of functions that are odd or even. Let's see now if we have functions that are neither. You see, so a typical example is as follows: is f of x equals to 1 over x minus 3 plus 2 x squared odd or even or neither. So let's see what happens here now. So let's first calculate f of minus x. So f of minus x is just 1 over minus x minus 3 plus 2x squared. You see, so we can see from here that this thing definitely is not equivalent to f of x. And also it's easy to see that f of x again is not equivalent to minus f of minus x, because we can see that this f of minus f of minus x is the same as just 1 over x plus 3 minus 2x squared. So we see that there is no equality there. So therefore f is neither odd nor even. You see, so you can see that yes, we can have functions that can neither be odd or even, just as these examples that we have seen here. So yeah, those are some basic things that you have to know when it comes to odd and even functions. But now what we're going to do now is we're going to conclude this lesson by looking at what properties do odd functions have and even functions have. So let's talk about geometric properties of even functions. You see. So what are the geometric properties of even functions? So one of the geometric properties of even function is as follows. You see that. So the graphs of even functions are symmetrical about the y-axis. You see that. So it's sometimes if you don't have a function explicitly, how can you tell? Because functions can be represented using many different techniques, and one way to represent them is by making use of graphical representation. So how can you tell if a function is either odd, even, or neither? Just by studying the graph. You can tell by using these facts. So a function which is even has this kind of property. It is symmetrical about the y-axis, and one example of such a function is the function, this one, like this. So if you are to come and draw a mirror line here along the y-axis, you will see that these two shapes on the left and on the right, they are reflections of each other around that line. So every time when this is the case, this is what you will see when you have an even function. So even functions, they are all symmetrical about the y-axis. You see, so when you look at the graph around the y-axis, then you will see that there's some sort of symmetry that is there. You see, so it's good to be aware of all these results. Then when it comes to odd functions, so odd functions are antisymmetric about the y-axis. So when it comes to odd functions, they have a skew symmetry about the y-axis. But what do we mean by that? So what we mean by that is that these functions, they have some this kind of pattern about the y-axis. So let's say maybe if one part of the graph here behaves like this, then the other part will not actually come and be a perfect reflection, but it will be more like they come here and behave in an opposite manner to what they are doing the other side. You see, so that's what we mean by skew symmetry. It's more like it's a symmetric thing, but about the y-axis and the x-axis, we still have the same shapes. You see, so if you look at these shapes, they are still identical. The one on the left and the one on the right, they are actually identical. But if you look this side, we see that it's flipped upside down. You see that? So this shape that we see here on the right-hand side, it is flipped this other side. You see, so that's what we mean by skew symmetry. So when we have this, we say a function is skew symmetric. So these are things that you should make sure that you are aware of when it comes to dealing with functions like that. You see. So yeah, these are some of the basic things that you should know when it comes to odd and even functions. Then now let's talk about something a little bit different now. So there is a nice theorem that you have to know. So I'll just write down something which I'll call a proposition. You see that? So if f, let's talk about functions from real numbers, is a function, then f of half of f of x plus f of minus x is an even function. You see that? So one thing that you should know is that if f is just any function, then half of f of x plus f2 minus 1x is an even function. And how can we prove that? Because you have to know how to prove that. So the proof of that, it goes as follows. So what I'm going to say now is I'll say let g be that thing. So I'll say let g of x be half of f of x plus f of minus x, and see what is going to happen. So now what is g minus x? So we agree that g minus x is same as saying half of f, where there is x we put minus x, so we get here f of x plus inside there we'll get x. But we can see that this is none other than the original thing that we have, because I can change the order inside to get this again. So we see that this is just the same as saying g of x. So therefore g of x is an even function. You see, so g of x is an even function, just simple like that. So it's a nice result that you should know. You are going to see its use as we continue with the discussion. So it's good to always know that if for any function, if you take half of f of x plus f of minus x, you will always get an even function. So there is another proposition also of a similar manner. So another proposition that you should know goes as follows. You see that? So if f from R to R is any function, then half of f of x minus f of minus x is an odd function. You see, so you should know that every time when f is a function, then that thing is odd. How can we prove that? So to prove that, we use the same logic that we did here. So to prove this, we'll say let g of x be that given thing, which is half f of x minus f of minus x. So this implies now what is g minus g of minus x. So it's minus half of, inside to multiply wherever there is x, we put minus x, so we get f of minus x minus f of x. Then what I'm going to do now, the negative that is inside, I'll pull it out. But when I pull it out, it will cancel the one sitting outside, and I'll just get f of x minus f of minus x. But this is just none other than g of x. So therefore, we can see now that g of x is an odd function. You see, so it's easy to see that here g of x is indeed an odd function. You see, so it turns out now that we now have a nice result that is quite useful also in function, which I'll state in the form of a theorem. So we have the following theorem that you can state. You see that? So if f, any function f, which takes real numbers to real numbers, can be written as a sum of odd and even functions. You see, so one of the things that you should know is that any function f which takes real numbers to real numbers can be written as a sum of odd and even functions. But how do we do that? How do we prove this result? How can you prove this result? You see that? So let f of x be any function. You see that? So let f of x be any function. So now what do we have? So we can agree that f of x is just the same thing as saying half of f of x plus half of f of x. We agree on that, because if I say half of f of x plus half, I go back to f of x. But also, this is the just same thing as saying half of f of x plus half of f of x plus half of f to minus x minus half of f to minus x. So if you look, these two terms that I introduced, they can just cancel each other because they are just equal to 0. So it's like I didn't change anything. But what I'm going to do now is I'm going to group these in pairs as follows. So I'll take first half f of x and pay it with f minus 1x. Then I'm going to take also half f of x and pay it with minus f of minus x. So if you look, this thing that we have here, we already proved in the previous problem that this is an even function. And also we proved in the previous proposition that this is an odd function. So we can see that any function can be written as a sum of an even function and an odd function. And those two functions, they are defined as follows. So we can see from this definition that if I refer to the even part as g(ax), then we can see that every time when you want to find that g(ax), you just have to use the formula f of x plus f of minus x. And if you want to find the odd part, which I call g of x, it is always given by half f of x minus f of minus x. So this is how you find the even and the odd components of any function that is given, you see. So let's put this into practice then and see what problems can one expect from this. So a typical example will be write down f of x equals to x cubed minus x squared as a sum of odd and even functions. You see, so you can be given any random function and you can be asked to write it as a sum of odd and even functions. So how can you go about that? So the best way to go about that first is to recall that the even part, which is g of x, is always given by half of the given function f of x plus f of minus x. So which means it's going to be half of f of x, which is x cubed minus x squared plus f of minus x. But f of minus x is where we put minus x wherever there is that, and minus x wherever there is that. So this simplifies to give us half. So you see here, this will cancel each other out when we simplify, and we'll get negative 2x squared, which gives us negative x squared. So definitely we can all see that this is indeed an even this is indeed an even function. If you want, let's say g of x now, we know that g of x is given by half of fx minus f of minus x. So this is equal to half of f of x, which is x cubed minus x squared, minus f of minus x. So what is f of minus x? So in negative x cubed, then minus again that, but this is going to be plus negative x squared, like that. Then we simply get half. Then we get x cubed minus x squared plus x cubed plus x squared. So we see these vanish and we just get half by 2x cubed, which is x cubed. So we see now that we get the components, the odd and the even components of this function as these. So if you look already, this function was just a sum already of odd and even functions, but we just wanted to verify to see that using those formulas that we've derived, are we going to exactly get the things that we expect to get? So we can see that things are coming out as we expect them. So yeah, that's all that we can say now when it comes to odd and even functions. So make sure to go through it and try to understand each and everything that was covered in this lesson. Otherwise, thank you guys for watching. See you next.